Every 9mm round begins not as a weapon, but as raw metal waiting to be shaped. Brass for casings and hardened lead for cores arrive under tight material control and safety rules.
Every batch is tagged, logged, and tracked before it ever reaches a single machine.
Dimensions, alloy composition, and surface finish are verified long before the first case is formed.
Lead hardness must stay within a narrow range to ensure bullets deform predictably and safely.
The most sensitive ingredient, the primer mix, stays under strict lock, procedure, and monitoring.
From the start, this factory is engineered as a continuous system, not a series of isolated machines.
Here, flat metal becomes the foundation of every 9mm cartridge case.
Thousands of perfect blanks are cut every minute, each destined to become a single casing. Multiple drawing stages stretch the brass without cracking it, preserving strength where it matters most. Each draw step is calculated, with pressure, lubrication, and temperature tightly controlled. Annealing softens the case mouth, preventing cracks when the bullet is finally seated.
Length is controlled within fractions of a millimeter, critical for pressure and feeding reliability. Even microscopic burrs can affect bullet seating and accuracy, so automation checks every edge.
The primer pocket and flash hole must channel ignition the same way, shot after shot. Dimensional control starts early, catching defects before more value is added downstream. Polishing removes machining residue, leaving clean surfaces for primers, powder, and projectiles. With raw materials shaped into precise casings, the next step is to give every round its spark.
Conveyors and simple gravity feeds link each process into one continuous production flow.
Material handling here is choreographed, moving thousands of components with minimal wasted motion.
Ammunition plants function like small cities, with traffic rules, routes, and priorities baked into their design.
While cases travel toward assembly, raw lead is on its own journey toward becoming precise bullet cores. Lead is melted and controlled to exact temperatures before it's forced into long, solid wires.
From liquid metal to solid wire, every diameter is tuned to match the exact mass of a 9mm projectile.
Each slug is a controlled weight, the starting point of consistent, repeatable bullet performance.
Jacket material feeds in just like the brass, destined to wrap each core in a precise copper skin.
These cups will become the familiar full metal jacket, protecting the bore and the core alike.
Swagging locks core and jacket into one solid projectile that will withstand acceleration and impact. Only bullets within narrow weight bands move forward to sit atop a carefully measured powder charge. Separate component streams converge here, timed and balanced to feed high-speed loading machines.
This hall is where cases, powder, and bullets finally come together as live 9mm cartridges. Internal transport ends here, where components are verified again before entering the loading equipment.
Gravity, vibration, and careful tooling keep every primed case properly oriented for safe loading. Now cases and bullets stand in parallel ranks, ready to be matched at speed and scale.
With internal logistics complete, every component now waits in position for the exacting harder and
Every shipment and every person is verified before crossing into this controlled environment.
The same people, the same shifts, and the same safety routines keep this high-risk product under control.
Behind these walls, millions of 9mm cartridges are formed, filled, tested, and shipped every year.
Office spaces sit up front, but the real story unfolds beyond the security doors, on the production floor.
This spine connects every major process, allowing supervisors to cross-check lines at a glance.
From this vantage, the plant feels less like a weapons factory and more like a precision-engineered machine.
Every parameter, from charge weight to crimp pressure, is visible to the human eye and logged by software.
Physical guarding and visual access strike a balance between safety and constant inspection.
Air quality and climate are carefully held within strict limits to keep powder behavior predictable. Bulk propellant is stored nearby, but always separated, monitored, and handled to explosive standards. Every contact point is grounded to prevent static, a small detail with massive safety implications. With exterior security and interior controls set, attention narrows back down to each tiny, moving case. Uniform lighting is another unseen tool, exposing any irregular movement or color that might signal a problem.
At the plant's edge, finished ammunition and raw materials cross the same threshold in opposite directions.
This is the plant's throat, where logistics, storage, and production schedules all converge.
Only fully inspected and documented rounds will eventually pass through these doors to wait for shipping.
Now, with the environment secured and the line balanced, each primed case is ready to receive its exact charge. One last human glance confirms what the instruments already know. Everything is ready to run live rounds. Every wall here reminds workers that precision isn't only about performance, it's also about safety and control. The factory exterior fades from view, and all attention narrows to this precise moment where controlled energy meets. Random sampling confirms the machine's precision, tightening control before error can accumulate. Software flags even subtle differences in powder height, ejecting anomalies before they become dangerous rounds. Automatic rejection makes sure that flawed charges are caught in milliseconds, not at the shooting range. Clean, consistent cases filled with precise charges now roll forward to meet their matching projectiles.
Direction matters. An upside-down bullet here would mean a dangerous malfunction later.
Gravity and timing work together, so every bullet finds its home in a waiting column of brass and powder. Seating depth and crimp shape pressure curves, so tolerances here are as tight as anywhere in the plant. Rounds that fall just outside nominal limits are not always scrapped. They may be pulled aside for careful human review. Light tumbling cleans away residue and presents every surface to the lens for a first visual check. High-speed imaging sees dents, scratches, and even tiny splits long before a human eye could. Even the tiny primer cup is inspected for tilt, cracks, or contamination that could affect ignition. From here, high-speed lines slow down again, so humans and machines can double-check the work together.
A final wash strips away oils and residue, leaving bright, clean surfaces for reliable feeding and packaging.
Chaos becomes order again, as loose cartridges align themselves for retail-ready presentation. Trays ensure that every round is separated, visible, and protected for its final inspections. Despite dense automation, a final human sweep catches the rare flaw machine logic might miss.
Cleaned, sorted, and approved, these 9mm rounds now leave the cleaning and sorting zone, heading toward their final shells of cardboard and shrink wrap.
Packaging starts with flat sheets of printed board, engineered to protect each cluster of 9mm rounds. Folding and gluing convert plain cardboard into a snug shell built around standard tray dimensions.
Formed cartons queue patiently, synchronized to meet filled ammo trays arriving from inspection.
Mechanical and electronic checks verify that every pocket holds exactly one properly seated round.
In a fraction of a second, 50 finished 9mm rounds move from exposed tray to protected retail pack.
Printed graphics on each lid explain in ink what the machinery has already guaranteed in metal.
Box-level weighing adds yet another layer, making sure no carton carries more or fewer rounds than promised.
Printed codes trace every box back to exact machines, materials, and shifts if a problem is ever found. Outputs from several lines synchronize here, feeding a shared end-of-line system that maximizes uptime. Shipping cases are built on demand, their dimensions tuned for specific carton counts and stack patterns. Automated hands stack dozens of retail boxes into shippable cases without dropping or scuffing a single one.
Each case becomes a traceable logistics unit, ready to be scanned at warehouses half a world away.
Even after assembly, an extra layer of inspection watches for unexpected contamination or missing product.
At full speed, thousands of rounds per minute quickly transform into tall, orderly towers of firepower.
A tight skin of film locks every case in place, guarding against shift and moisture in transit. Digital records link each pallet to its internal history, from metal coil and powder drum to final pack. From precise mechanical motions to heavy lift logistics, the product now leaves the packaging line behind.
On the far side of this threshold, 9mm ammo waits not for more processing, but for orders and outbound trucks. Storage is organized like a three-dimensional spreadsheet, every pallet occupying a known cell in space. With cases formed, rounds loaded, and cartons sealed, the finished 9mm ammunition now rests, ready for dispatch whenever the world calls.
Before a lot is cleared, sample rounds are sacrificed in special barrels that measure pressure and speed.
Sensors at the chamber and case mouth turn each shot into a curve of data instead of just noise and recoil. Peak pressure, rise time, and burn profile must all fall inside a narrow tunnel drawn by standards bodies.
Fired brass tells a hidden story. Too much pressure leaves scars that no chart can hide. Sealed primers and case mouths must keep water out, ensuring the round still fires after getting soaked. Rounds are aged briefly in climates harsher than most users will ever see in real life. Sampling plans define exactly how many rounds must prove themselves before a lot can be trusted.
Even test firing happens under strict range rules, treating every sample like a live mission.
Groups are measured in fractions of an inch, translating factory consistency into confidence on the range.
Data from dozens of sensors condense into one verdict: accept the lot or send it back for correction.
Pull-downs verify that what the machines intend to meter and seat is exactly what ends up in the field.
Long-term charts catch drift early, long before dimensions or ballistics wander out of tolerance.
No pallet can ship without a chain of signatures linking data, metal, and responsibility together.
Digital twins of the warehouse keep track of every lot that has passed, failed, or waits for its turn.
Some buyers demand extra proof, so the factory runs side tests tailored to their own specifications.
Retained samples and records make it possible to revisit and retest if questions arise years later.
Audits on the live line ensure day-to-day work still matches the procedures written months before.
Problems become data, and data becomes action, closing the loop between inspection and improvement. Only after passing ballistic and functional trials does this ammunition move to the front of the shipping queue.
With quality signed off and lots assigned to orders,
the journey of each 9mm round turns out.
This factory doesn't just run, it listens to itself.
logging every stroke, jam, and microsecond of downtime.
Data flows from every motor and sensor, turning the whole line into a live performance chart.
Priming is guarded by a halo of sensors, watching every pocket and punch with millisecond resolution.
Machine vision replaces tired eyes, spotting empty or overfilled cases at full production speed.
Laser gauging captures dimensions too subtle for calipers, logging each round as a data point, not just a sample.
Every reject is tagged with a reason, helping engineers trace problems back to a tool, batch, or operator.
Robots here don't just move parts. They help reroute flow in real time when one station slows down.
Self-tuning feeders adjust themselves, smoothing out small disturbances before humans ever notice.
Instead of waiting for a breakdown, sensors forecast when parts will tire, scheduling service into the plan.
From here, a handful of specialists watch thousands of data points instead of thousands of stations.
The smart line protects itself, trading a small slowdown now for avoiding a complete stoppage later.
Driverless carts handle repetitive runs, freeing operators to focus on quality, setup, and supervision. Storage and retrieval blend human drivers with guided machines, each doing what they do best. If a single defect is found later, trace codes can walk investigators backward through every machine it saw.
Instructions live on screens, not in binders, so updates roll out in minutes instead of weeks.
Historical data doesn't just prove what happened, it points out where small changes made big gains.
Centralized alarms keep the noise down, so the few signals that matter never get ignored.
New ideas are tested in pixels first, letting teams rehearse changes before touching real metal.
Human insight feeds back into the system, so the smartest parts of the factory are still the people.
Power and air are treated like materials, measured, managed, and trimmed wherever possible.
The more connected the factory becomes, the more its nervous system needs strong digital armor. Here, Industry 4.0 meets brass and lead, where algorithms inspect every round before it ever reaches a box.
Even after assembly, cartridges are polished one last time, so surface flaws can't hide in grime.
The groove and rim must match the pistol's claw perfectly, or flawless combustion will still fail to extract.
Head stamps are the cartridge's passport, tying every round to its maker, caliber, and production history. High primers can cause jams, low primers can cause misfires. Both are eliminated before boxing. A straight bullet path begins at the factory, long before it meets rifling in a barrel.
Crimp too light and bullets creep under recoil. Too heavy and pressures spike. Both show up clearly in profile.
Inspectors train against a standard library, so good enough means the same thing for every shift.
Human touch complements machine vision, catching subtle flaws that instruments might ignore but shooters would notice.
If it doesn't sit right in a gauge block here, it won't seat right in a pistol mag or chamber later.
Dimensional spot checks confirm that automated gauges are still telling the truth. A tiny ring of letters and numbers helps law enforcement and armed forces trace ammo back to its source.
A carefully controlled film helps cartridges survive warehouse time and climate swings without tarnish.
Images document exactly what good looked like on the day each lot left the factory.
Even after all earlier checks, the line still counts, because customers buy ammunition by the exact round.
One more signature joins the chain of accountability, tying real names to every passing round.
Precision here isn't an occasional achievement. It's the everyday look of standard production. With finishing complete, each tray of 9mm rounds is now worthy of its box, its pallet, and finally its end user. A final snapshot preserves what perfection looked like a split second before these rounds disappear into cardboard.
From microscopic checks to macro logistics, every step has prepared these 9mm rounds for the outside world. Beyond the noise of presses, a quieter side of the factory dissects samples to prove every lot's quality.
Each sample round is registered, so any measurement can be traced back to a specific machine and shift.
Lab measurements confirm what inline gauges report, anchoring production data to certified instruments.
Full down rounds reveal exactly how much powder actually made it into the case, not just what was targeted.
Primer tests map how reliably a firing pin impact will light the spark that drives every bullet forward. Neck tension must hold bullets firmly enough for storage and recoil, but still allow consistent release in the barrel.
Chemical checks verify that each batch of powder burns the way the ballistics tables expect it to burn.
Microscopic residues reveal whether primer chemistry remains within the expected safe and reliable formula.
Harsh conditioning compresses years of storage into days, checking if seals and coatings can take real-world abuse.
Standardized pressure tests ensure every lot meets the same global rules, whether for military or commercial use.
Sampling plans turn thousands of rounds into a handful of representatives that statistically speak for the whole lot. Sectioned brass shows whether drawing and annealing left walls strong where they must be and soft where they should flex. Cut-open projectiles confirm that what's hidden inside still matches the engineer's original blueprint. All lab work converges into a single document that states, in writing, that this ammunition meets its spec.
Quality results never stay trapped in the lab. They flow back to the floor to keep tomorrow's rounds even better.
With lab signatures in place, the lot is finally free to leave the factory's inner circle and head toward the loading docks. Approved lots move from quiet racks to a busy staging lane, queued up for their turn on a truck. Each pallet is handled like a single unit, but inside are thousands of cartridges now bound for the outside world. Loading starts only after the dock, trailer, and paperwork line up in a controlled, repeatable routine. Blocking and bracing lock the ammo in place so nothing shifts when kilometers of road start shaking the steel. Scans and seals tie cargo, truck, and paperwork together, forming a chain that shows if anything has been disturbed. Regulations dictate how each load is described, marked, and documented before the wheels ever roll. The driver leaves with clear instructions, legal notices, and a record linking him to the cargo behind. With each departure, a slice of the warehouse becomes lighter, and the world outside gains new stock.
As pallets leave, systems nudge production plans, keeping shelves and customers supplied without flooding storage.
Regular spot counts confirm that digital inventory still matches what's wrapped in plastic and stacked on steel. Some shipments stay close to home, feeding local ranges, agencies, and retailers that rely on steady supply.
For export orders, the entire unit load rides inside a steel box, ready for trucks, trains, or ships. From raw coil to boxed rounds, crews hand off responsibilities, but the product's story stays continuous. Here the story pauses, tens of thousands of rounds resting in perfect order, waiting to be called into use.
Pallets sit in numbered slots, every one mapped in the warehouse system and ready to be located in seconds.
Multiple outbound streams tie the plant to a web of depots, distributors, and end users across the map.
Every departure leaves a paper and digital trail, showing who approved what and when, in case questions ever return.
And this is how modern factories produce 9mm ammunition from start to finish.
From molten lead and brass coils to sealed pallets and outbound trucks, every meter of this site is part of one continuous system.
If this journey through real manufacturing helps you see every round differently, there's more to explore. Subscribe for more real factory breakdowns. Subscribe for more real factory breakdowns.
Every episode reveals another hidden world where industrial engineering shapes the products we use.
Thank you for watching.